Hey guys, my name is Miss Berg. We're going to be going over some new chemistry stuff today. Miss Flores is out again sick today, so you guys are going to watch this video, and I'm going to show you how to do the calculations that she would have taught you, and then you guys will be able to do them on your own. All right, so here we go. So today we're going to learn about molar unit conversions. So first of all, what is a mole? No, not this kind of mole. Also not this kind of mole, and definitely not mole A. Okay, so what a mole is, in chemistry, a mole is just a number. Okay, it's like saying a dozen. Okay, so a dozen we know means 12. A mole is a number as well. It's just a really, really, really big number. Okay, so the way we would say what a mole is, if we were going to say the actual number, would be 602 hexillion. Okay, which is really big. What we normally end up saying, how we normally end up saying this, is 6.02 times 10 to the 23rd. Okay, that's the way we're going to write it, and that's the way we're going to say it in class. So when I say it's really big, I mean it's really, really big. Okay, so when we talk about a mole of something, okay, we end up having a ton of that thing, or 602 hexillions of that thing. So if we had a mole of donuts, okay, it would cover the entire Earth, an 8-kilometer thick layer of donuts. So if you look at this little image down here, okay, this is our Earth, and this is how thick the layer of donuts would be around the Earth if we had a mole of donuts. Okay, our next example we're going to look at is basketballs. Okay, if we had a mole of basketballs, you could create a planet the exact same size as the Earth made up of just basketballs if we had 602 hexillions, or 6.02 times 10 to the 23rd basketballs. So now you're kind of getting an idea of how we measure what a mole is. Okay, so another example, if you had a mole of pennies, the day you were born, you could spend basically $1 million every second until the day that you turned 100 years old, and you would have only spent 0.1% of your money, 0.01%, I'm sorry, 0.01% of your money, so you would still have a heck of a lot of money left over. A mole of blood cells is more blood cells than every person on Earth has combined. So again, like we said, a mole is a really, really, really big number. Now, why do we care about a mole? Why do we care what a mole is? So a mole is really useful in chemistry when we're talking about reactions, because molecules are so tiny that we can have a ton of them, or a mole of them, and it not take up very much space. Okay, so for example, a glass of water contains billions and billions of molecules of H2O. Okay, it would be very difficult to count them all, but we could easily say we have a mole, okay, of H2O, so we would have 602 hexillions of those molecules, and we could have that in a small container. So it's a good way for us to measure them. So what we're going to do today, we're going to practice some real simple calculations involving molecules, atoms, and moles. And the way that I kind of want you guys to think about this, or when we approach these problems, think about it this way. If I were to ask you how many eggs are in 4 dozen eggs, so what would we do? Okay, so we know that 4 dozen, okay, we know what a dozen is, right? A dozen is 12 eggs. So if we have 4 dozen eggs, how many eggs would we have? Okay, so we would do 4 times 12 to find that number. Okay, another example, how many dozen oranges do 36 oranges make? Okay, well, we know that 36 oranges, if we divide that by 12, it'll tell us the number of dozens that we have, because a dozen is just 12. Okay, if you can answer these simple questions, then you can easily do mole to molecule conversions as well. Okay, so I'm going to go ahead and pause for a second, and then I will show you guys how to actually work out these calculations on paper.
Okay guys, I'm going to go ahead and show you how to work these really simple dimensional analysis problems. So for example, we're just going to start with the easy dozen eggs example. Okay, so if we were given that there's 4 dozen eggs and we wanted to see how many eggs are in this 4 dozen eggs, okay, we would start and we would say 4 dozen eggs. Okay, we draw our train tracks. Okay, and we would say we know that for every 1 dozen, okay, 1 dozen eggs, we have 12 eggs. Okay, so when we get that, what this is going to tell us, okay, is that what we're going to do is, because it's next to each other on this dimensional analysis track, it's going to be multiplied. Okay, so this is going to be 4 times 12, okay, which would give us our 48 eggs. Okay, so that go ahead. We worked out that problem. We know we have 48 eggs then. Okay, the way you can check to make sure you did this right is your units are going to have to cancel out. So I had dozen eggs here, and I have dozen eggs here, so I know those will cancel each other out. Okay, so check, check. Okay, we know that we're going to be left with just eggs, which is what we wanted. Okay, eggs to eggs. Okay, so that's one really easy sample problem. Okay, now let's try it with a little bit of a harder problem. We're actually going to work one of the moles to molecules problems. Okay, so one of the examples from our little PowerPoint that we went through wants to know how many molecules. So how many molecules are in 4 moles of water? Okay, so here's our question. How many molecules are in 4 moles of water? Okay, so what does our problem give us? Okay, the given here is going to be 4 moles of water, so that's what we're going to start with. Okay, so we'll go over here and we'll say, okay, 4 moles of water, 4 moles of H2O, and we'll draw our train track. Okay, if we have moles of H2O on the top, what do we have to put down here in order to cancel it out? Okay, we're going to have moles of H2O here. Okay, and we know that we're ending up looking for molecules, so we want to have molecules up here. Okay, what do we know about moles to molecules? Well, we know that every 1 mole is equal to 6.02 times 10 to the 23rd molecules. Okay, because these two numbers are next to each other, what do we do with them? We're going to multiply. Okay, so your answer is going to be 4 times 6.02 times 10 to the 23rd molecules. Okay, so we'll do that real quick. Okay, so basically what we would get, you want to put it in your scientific calculator, which I don't have, so I can't show you that. But what I did was I went ahead and multiplied 4 times the 6.02, which gives me 24.08. Okay, with scientific notation, I only want one of my numbers to be in front of there. So I'm going to put 2.4 times 10 to the 24th. Okay, and then I have to put my units on there. So that would be molecules. Okay, when we put that in our calculator, okay, we're going to put 4 in, and then we're going to put in times. Okay, and then we'll do 6.02, and then we'll put that E symbol, and then to the 23rd. Okay, I'm going to get a scientific calculator, and I'll show you guys how to do that on the scientific calculator. Okay, I got a scientific calculator. So the way that you would put this in your calculator is you would say 4, and then multiply, so times, and then you would do 6.02, and you would do second E, which is right here, this little E button. Okay, and then you would do 23. Okay, so that's the way we write 6.02 times 10 to the 23rd in the calculator. You hit enter, and it gives you 2.408 E24. So the way you would write this on your paper would be 2.4 times 10 to the 24th. Okay, because remember, E23 meant times 10 to the 23rd. So E24 means times 10 to the 24th. Okay, so we practiced that one. Let's go ahead and do one more. Okay, so this next problem that we're going to do, okay, it's saying if you have 1.2 times 10 to the 24th molecules of NH3, how many moles of NH3 do you have? Okay, so again, what is the given here? Okay, they're giving us 1.2 times 10 to the 24th molecules, and they're asking us to find moles. Okay, so we want moles. We put a little question mark next to moles because that's what we're looking for. Okay, so again, you start with what you're given. So we would say 1.2 times 10 to the 24th molecules. Okay, I'm going to draw our train tracks. Okay, I'm sorry, molecules of NH3. We have to write that. Okay, so molecules of NH3. So if we have molecules of NH3 here, what do we know we have to have down here? So it'll cancel out. We know it's going to have to be molecules of NH3. Okay, so up here, what we want will end up being moles. Okay, so we go ahead and we know our conversion from moles to molecules. Okay, for every 1 mole, we have 6.02 times 10 to the 23rd molecules. Okay, so now we've got a different problem here. Because whereas we would multiply when our numbers were next to each other, now that they're on top and bottom, we have to divide. Okay, so pause just a second and I'll show you guys how to do this on the calculator. Okay, so let's go ahead and put our problem into the calculator. Okay, so you can see we're starting with 1.2 times 10 to the 24th molecules. Okay, and we're going to end up with moles. So we have to put 2 different molecules into the calculator and divide them. Okay, so when we're going to do that, we always have to use parentheses because we have that little e with our exponent there. Okay, so always use parentheses with those. I'm going to show you guys how to do this. Okay, so for example, okay, we're going to put, because we're starting with 1.2 times 10 to the 24th, that's going to be the first number we put in. Okay, it'll be on top of our equation just like it is here, this divided by this. Okay, so we'll do parentheses, 1.2, second e, 24, because it was times 10 to the 24th. And we're going to divide, close the parentheses, then hit divide. Open another set of parentheses and do 6.02, second e, and then 23. 6.02 times 10 to the 23rd. Close your parentheses and hit enter. Okay, so that's going to be 1.99. Okay, so our answer here would be 1.99 moles of NH3. Okay, or we should have put NH3 here. Sorry, that's my fault. And then you can cross out molecules of NH3, molecules of NH3, because we canceled those out. Okay, so your answer should be right here, 1.99 moles of NH3. Okay, so those are some of our sample problems. I'm going to show you guys the worksheet that you have to do. We're going to work through maybe 1 or 2 of them together, and then you guys will be able to finish the rest of it on your own. Okay, so this is your homework page. Okay, I'm going to go ahead and work the first problem with you on here, and I'm going to show you something called a mole map that I want you guys to start using for these problems. The first day when we use this, it's going to be kind of easy because we're just doing conversions from moles to molecules. We're also going to do moles to grams, and we're going to end up doing moles to liters also. Okay, so when you do this mole map, you want to first just draw an uppercase Y like this. Okay, in the middle of your map, okay, so where the Y or where all the points meet, I want you to write 1 mole. Okay, 1 mole is going to be like home base. Okay, this is where we're always going to come back to. Okay, up in this corner over here, I want you to write molecules. Okay, down here, we'll go ahead and write grams. And then up in this corner over here, we'll write liters. And this is going to be the way you'll always set up your mole map. Okay, the only portion of the map that we're going to be using today is going to be right here. Okay, we're just going to be going from molecules to moles and moles back to molecules. Okay, on this little part of the Y here, I'm going to have you write your conversion factor, which is going to be 6.02 times 10 to the 23rd. Okay, the number we were working with earlier, 6.02 times 10 to the 23rd. Okay, so now let's go to our first problem. I'm going to show you guys how I would work this. First of all, you're always going to underline the given. Okay, you can even come over here and say G for given. Okay, and you write in 3 moles. Okay, that's what you were given. Okay, I always put a question mark. Okay, that's what the question is looking for. What does the question want? It wants molecules. Okay, so I would come over here and say my question wants molecules. Okay, then I set it up. We start with what we're given, so 3 moles of NO2. Remember to always put your molecule that you're working with. So we've got 3 moles of NO2, or your compound you're working with, sorry. Okay, if I have moles of NO2 up here, then I have to have that cancel out down here. So I'm going to go ahead and write in my moles NO2. Okay, and what is it that I'm looking for? Molecules. So I'm going to go ahead and write that in here. then I find this conversion factor. Remember, we said 1 mole is equal to 6.02 times 10 to the 23rd molecules. Okay, so we'll go ahead and say, well, 1 mole is equal to 6.02 times 10 to the 23rd molecules. Okay, that's where your calculator comes in. Okay, remember, because they're next to each other on the top, okay, or next to each other, and if they were both on the bottom, we'd still multiply. Okay, so we're going to multiply because they're next to each other, so write your little X on the cross. So you'll say 3, oops, sorry, I got to turn it on, 3 times, remember, we're going to use our parentheses, 6.02 second E, 23, okay, and that's going to give us 1.806 times 10 to the 24th. And my mole map's in my way, so I'll just make it really long like this, and I'll say 1.8. We'll just say 1.81, we'll round, and then times 10 to the 24th molecules. Now remember, don't try to shorten the word molecules to moles, because that's totally two different things. Okay, 1 mole is equal to this many molecules, so you can't just say moles here to abbreviate molecules. That won't work. They're not the same thing. Okay? So that was our first practice problem that we were going to do together. Okay, now I want you guys to go down and look at number 6. Okay, we're also going to do number 6 together. Okay, so number 6 says, how many moles are contained in 2.5 times 10 to the 20th atoms of Fe? Okay, atoms and molecules can be used interchangeably if the compound you're working with, or the thing that you're working with, is an element. Okay, because there's only one atom in this thing. Okay, so this can be used interchangeably with molecules. But if you come to a problem later where you're looking at something like, let's look at this one. How many atoms of oxygen are there in 2.5 moles of O2? You have to be careful here because for every molecule of O2, there's 2 atoms. So you would have to multiply the final number by 2. Okay? All right, so let's go back to number 6. Okay, remember our first step, we should be looking at that mole map. Okay, I'm only going to draw in the portion of the mole map that we're using today. So this is 1 mole. And then we've got molecules here. And what was our conversion factor? 6.02 times 10 to the 23rd. Okay, so we've got our mole map. We've got our problem. Okay, we want to underline the given. So again, our given is 2.50 times 10 to the 20th atoms. Okay, which we can use interchangeably with molecule here because we're dealing with just iron, or just one atom per molecule. Okay, and then for our what we want is going to be moles. Okay, so again, over here, you're going to put in your G for your given. Is going to be 2.50 times 10 to the 20th atoms. Okay, which we use the same thing as molecules. And then what we're looking for is going to be moles. Okay, so start with what you're given. 2.50 times 10 to the 20th atoms. Okay, remember, because we have atoms here, we want atoms on the bottom. Okay, so we'll say atoms down here. Remember, we said we could use atoms interchangeably with molecules. So it's going to be 6.02 times 10 to the 23rd atoms is equal to 1 mole. Okay. Now, because we've got one number on the top and one number on the bottom, we're going to have to turn this into a division sign. So it'd be like, do like this, we'll make it a divide sign. Okay, so in our calculator, okay, you would put in your 2.5 second E 20, because it's 2.5 times 10 to the 20th. Okay, and then we're going to divide that by 6.02 second E 23. And the answer we get is going to be we'll say 4.2. because it's 4.15. So 4.2 times 10 to the negative 4th moles. So it's a very small number. Okay? Alright, so there's your 2 practice problems and how to draw out your mole map. You guys can do the rest of the worksheet on your own. Good luck, and make sure you check with Miss Flores when she gets back to make sure that you understand what you're doing.